My name is Chancellor Coger,
I'm Quincy Zook.
and this is our project. The design problem is basing a material off of parts that are used in a car, and there's a set of requirements for each material, or for each part, and we will go over that for the fan shroud, the cowl tray, splash panels, and the mirror housing. So first we have the fan shroud material. This part is connected to the radiator and holds on to the cooling fan. The requirements are it needs to be a stiff material that does not deflect, high heat resistance, and it's lightweight. And this is the material I chose was polypropylene 620 by 2. These are the properties. It has low density, which is lightweight for the overall weight of the car. It has a very high melting point as it will be in the engine bay, and it exceeds the requirement of 200 degrees Fahrenheit. The tensile and flexorous modulus is high, which is good for impact for the inside of the engine bay. For testing and processing, we have the melting point, and it shows the test used for the melting point, as well as the tensile modulus, and 3-point bend test and tensile stressing for those. The injection process will be used to process it, and for this particular material, it is optimized for easy flow when going into the barrel. Next, we have the cowl tray. This is below the windshield that keeps water and heat from the engine. It protects the electrical parts, and it also can take impact from the breeze, so it's supposed to be strong in that way. Reasonable surface appearance. It doesn't want to be bumpy. It doesn't technically have to be a Class A finish, but somewhat good looking enough. High UV durability, as it will be exposed to the sun for long periods of time, and like I said, good impact testing. I decided to go with 10% glass filler, reinforced polypropylene, and UV stabilized, as well as black color. The properties, like I said, it needs to be UV stabilized, as it will be in the sun. So it has that. The tensile modulus is very high, so it's good for impact, for the debris that may hit it. And the deflection temperature is way higher than what it would be exposed to in the sun. As you can see, 205 degrees is way higher than what it needs to be, so that's good. For testing, I give you the UV resistance testing that will see how much UV light it can take before it deteriorates, as well as an impact test for a Charpy test. And this part will just be injection molded.
My part is the splash panels, which are inside the wheel wells of the vehicle. They separate the engine from the wheels and protect the engine from any sort of spray, rocks, debris that the tires may pick up. So requirements, some form of impact resistance, just because of those materials coming in. It protects and keeps those materials away from the engine. Dimensional stability and vibration dampening. So the polymer that I decided to go with was Polytrope CB1010U-330 TPO, which is thermoplastic olefinic elastomer. Some of the properties, it has a hardness of 63 Shore, which makes sure that it has a good hardness to be able to take impacts. Has a tensile strength of 3,000 PSI. We have a Gardner impact test, which uses a point on the material that has a defined radius that a weight is then dropped on, and it pushes that radius into the material to test the impact strength. We got a reading of 26.6 foot-pounds at -22 degrees Fahrenheit, and this will ensure that it's able to take an impact at low temperatures. And we also have a dimensional shrinkage of 17 thousandths at 120 degrees Celsius. The last part is the mirror housing. This holds the motors and the mirrors on the vehicle, and they're mounted on either side of the car. So the requirements are Class A finish, needs to look good, molded black or silver color, structural stiffness so that there's no vibration, and impact resistance. So the polymer that I chose was Auroran ABS. Tensile strength was 6,530 PSI. We have a melt temperature of 482 degrees Fahrenheit. We have a Charpy unnotched test of 38.1 foot-pounds per square inch at 22 degrees Fahrenheit and 57.1 feet-pounds per inch squared at 73.4 degrees Fahrenheit. And this will ensure that it has good impact strength qualities at both low and high temperatures. We also have the Sharpie notch test. We got a reading of 3.33 foot-pounds per square inch at negative 22 degrees Fahrenheit, and 5.71 foot-pounds per square inch at 73.4 degrees Fahrenheit. Basically, a Sharpie test uses a weighted hammer that is raised and is then let go and hits the material, which then it's a destructive form of the testing, so it breaks the sample. One of them is unnotched, which means it's just a straight bar, and the other one is notched. And from this, we can get the impact characteristics of the material.
References we used, and if you guys have any questions, please let us know. Thank you. Cool.